Azure Redis Essentials for Beginners. Hello and welcome to our channel, Enthusiastic Tech Learner. Today we have an exciting tech video in store for you. We'll be diving into Azure Redis Cache basics, exploring its features, and providing you with valuable insights. Whether you're a tech enthusiast, a beginner, or just curious about the latest in the tech world, you're in the right place. So without further ado, let's jump right into it. Topics covered in this video. Introduction to Azure Redis Cache. Getting started with Azure Redis Cache. Optimizing Azure Redis Cache performance. Securing your Azure Redis Cache. Redis Cache data persistence. Using Azure Redis Cache with .NET. Scaling Azure Redis Cache. Monitoring and diagnostics in Azure Redis Cache. Azure Redis Cache for session state management. Redis Cache Geo-Replication. Using Redis Cache with Azure functions. Redis Cache best practices. Real-world use cases. Comparing Azure Redis Cache to other Azure caching solutions. Troubleshooting common Redis Cache issues. One introduction to Azure Redis Cache. Azure Redis Cache is a powerful and fully managed in-memory data store service offered by Microsoft Azure. It's based on the popular open-source Redis database system, known for its speed, versatility, and support for various data structures. Azure Redis Cache takes these qualities and enhances them with Azure scalability, high availability, and seamless integration with other Azure services. Key features and benefits. In-memory data store, Azure Redis Cache stores data in memory, allowing for extremely fast read and write operations. This makes it ideal for use cases that require low-latency data access, such as caching frequently accessed data or session state management in web applications. Data structure support. Redis is not just a simple key-value store. It supports various data structures, including strings, lists, sets, sorted sets, hashes, bitmaps, and more. This flexibility allows developers to model and manipulate data in ways that fit their specific application needs. Highly scalable, Azure Redis Cache can be easily scaled up or down to accommodate changing workloads. You can vertically scale by choosing a larger cache size or horizontally scale by using Redis clustering to handle increased data storage and throughput requirements. Data persistence options. It offers multiple data persistence options, including RDB snapshots and AF logs, giving you control over how your data is persisted for durability. Security. Azure Redis Cache provides various security features, including SSL encryption for data in transit, access control lists (ACLs) to restrict access, and private endpoints for secure network communication. Integration with Azure services. It seamlessly integrates with other Azure services, allowing you to build applications that leverage the power of Azure Cosmos DB, Azure Functions, Azure App Service, and more. High availability. Azure Redis Cache ensures high availability through data replication and automatic failover. In the event of a failure, your application can continue to operate with minimal disruption. Monitoring and diagnostics. It offers built-in monitoring capabilities through Azure Monitor, providing insights into cache performance and health. You can also set up alerts to proactively respond to issues. Common use cases. Caching. Storing frequently accessed data in Azure Redis Cache to reduce database load and improve application performance. Session state management. Managing session data for web applications, ensuring that user sessions remain responsive and stateful. Real-time analytics. Processing and analyzing real-time data, such as user behavior or IT telemetry, by leveraging Redis fast data retrieval capabilities. Leaderboards and counters. Implementing leaderboards, counters, and statistics in gaming and social applications. Message broker. Acting as a high-performance message broker for pub/sub, publish/subscribe, messaging patterns, and task queues. Distributed locking, implementing distributed locks for coordinating actions across multiple instances of an application. 2. Getting started with Azure Redis Cache. Azure Redis Cache is a powerful tool for improving the performance and scalability of your applications by providing a fast and reliable in-memory data store. This guide will walk you through the essential steps to get started with Azure Redis Cache. Step 1. Create an Azure account. If you don't already have an Azure account, you'll need to create one. You can sign up for a free Azure account or use an existing one. Azure Redis Cache can be provisioned using various pricing tiers, so make sure your Azure subscription meets your requirements. Step 2. Access the Azure portal. Log into the Azure portal using your Azure account credentials. Step 3. Create a Redis cache. In the Azure portal, click on the plus Create a Resource button. Search for Redis Cache in the search bar and select it from the results. Click the Create button to begin configuring your Redis Cache instance. Fill out the necessary information. Subscription. Choose your Azure subscription. Resource group. Create a new resource group or select an existing one to organize your resources. Name. Choose a unique name for your Redis cache. Location. Select the Azure region where your cache will be hosted. Cache type. Choose a cache type, example, standard, or premium. Replication. Choose the replication type based on your availability and durability requirements. Virtual network. Configure network settings if needed. Step 4. Access connection information. Once your Redis cache instance is created, you can access the connection information you'll need to connect to it. Here's how. In the Azure portal, navigate to your Redis cache resource. Under the Settings section, click on Access Keys. Here, you'll find the primary and secondary connection strings. These strings contain the necessary information to connect to your Redis cache, including the host name, port, and access keys. Step 5. Connect to Azure Redis Cache. You can connect to Azure Redis Cache using various programming languages and libraries, including .NET, Node.js, Python, and more. Here's a general outline of the steps to connect. Install a Redis client library for your programming language. Use the primary or secondary connection string from the Azure portal to establish a connection to your Redis cache instance in your application code. Start using Redis commands to store and retrieve data in your cache. Here's a simple example in Python using the Redis PY library. This example demonstrates connecting to Azure Redis Cache and performing basic operations. 3. Optimizing Redis cache performance. Optimizing Azure Redis Cache performance. Azure Redis Cache is a high-performance, in-memory data store, but there are several strategies and best practices you can employ to further optimize its performance. This guide will help you get the most out of your Azure Redis Cache instance. Choose the right cache size. Select a cache size that accommodates your workload. Azure Redis Cache offers various cache sizes, and choosing the appropriate one ensures you have enough memory for your data and reduces the likelihood of cache evictions. Data modeling. Consider your data structures carefully. Redis supports various data types, strings, lists, sets, hashes, etc. Choosing the right data structure for your data and access patterns can significantly impact performance. Efficient data storage. Use Redis hashes for storing objects with multiple fields. This reduces memory overhead compared to individual keys for each field. Pipelining commands. Redis allows you to pipeline commands, which means sending multiple commands to the server in one go. This reduces the number of round trips between your application and the Redis server, improving performance. Use connection pooling. Implement connection pooling in your application to reduce the overhead of opening and closing connections to Redis. Many Redis client libraries support connection pooling. Proper cache expiry. Set appropriate expiration times for cache keys. Data that is no longer needed should be automatically removed from the cache to free up memory. Redis clustering. For high-throughput scenarios, consider using Redis clustering to horizontally scale your cache. This distributes data across multiple shards, allowing you to handle larger workloads. Monitoring and optimization. Regularly monitor your cache's performance using Azure Monitor and other tools. Analyze cache misses, memory usage, and latency to identify bottlenecks and optimize your usage. Implement caching strategies. Utilize caching strategies such as lazy loading and cache aside to load data into the cache only when needed. This reduces the initial cache fill load and optimizes cache utilization. Avoid hotkeys. Be cautious of hotkeys, keys that are accessed frequently by many clients simultaneously. They can cause contention and slow down your cache. Consider sharding data or using Redis cluster to distribute the load. Enable Redis persistence. If data durability is crucial, consider enabling Redis persistence options like RDB snapshots and AF logs. However, be aware that these options may have a slight impact on write performance. Redis Streams. Redis Streams is a powerful feature for building real-time applications. Utilize it for event-driven architectures or message processing to enhance performance and scalability. Use read replicas. Azure Redis Cache Premium offers read replica support. Utilize read replicas for read-heavy workloads to offload the primary cache and improve read performance. Security and access control. Implement proper security measures, including firewalls, access control lists, ACLs, and encryption to protect your cache and ensure only authorized users can access it. Regularly update client libraries. Keep your Redis client libraries up to date. New versions often come with performance improvements and bug fixes. By following these optimization techniques and regularly monitoring your Azure Redis Cache instance, you can ensure that your application benefits from the high-speed data access and reliability that Redis caching provides. Remember that performance optimization is an ongoing process that should evolve with your application's needs and usage patterns. 4. Securing your Azure Redis Cache. Securing your Azure Redis Cache is critical to protect sensitive data and ensure that only authorized users and applications can access it. Here are essential steps and best practices to enhance the security of your Redis Cache instance. Access control. Use access control lists ACLs to restrict access to your Redis cache. ACLs allow you to specify which IP addresses or Azure Virtual Network subnets are allowed to connect to the cache. Virtual network integration. To enhance security further, consider placing your Redis cache inside a virtual network, VNet, using Azure Private Link. This prevents public internet access and ensures that only resources within the VNet can access the cache. Firewall rules. Configure firewall rules to explicitly allow or deny traffic to your Redis cache instance based on IP addresses or IP ranges. This helps filter incoming connections and adds an extra layer of security. Encryption in transit. Enable SSL Secure Sockets Layer, encryption for data in transit. This ensures that data sent between your application and the Redis cache is encrypted and secure. Authentication. Use strong authentication mechanisms to access your Redis cache. Azure Redis Cache supports both access keys and Azure Active Directory, Azure AD authentication. Consider using Azure AD for managing authentication and access control for your cache. Rotate access keys. Regularly rotate your access keys to minimize the risk of unauthorized access due to compromised credentials. Azure Key Vault can help securely manage and automate key rotation. Role-based access control, RBC. If you're using Azure AD authentication, implement RBC to assign roles and permissions to users and applications. This fine-grained control ensures that only authorized entities can interact with the cache. Monitoring and logging. Enable diagnostic logging for your Redis cache instance. Monitor and review logs for any suspicious activity or access attempts. Azure Monitor can provide valuable insights into cache performance and security. Network security groups (NSGs). Consider using network security groups to control inbound and outbound traffic to and from your Redis cache. NSGs can help you define network rules and restrict access further. Redis AUTH command. Implement the Redis AUTH command to require a password for client connections. This adds an additional layer of authentication on top of Azure-specific security measures. Geo-Replication security. If you're using Geo-Replication for disaster recovery or high availability, ensure that security measures are consistent across primary and secondary cache instances. Regular audits and vulnerability scanning. Conduct security audits and vulnerability scans to identify and address potential security weaknesses or misconfigurations. Compliance standards. If your application needs to adhere to specific compliance standards, example, GDPR, HIPAA, ensure that your Redis cache setup aligns with those requirements. Keep software updated. Keep your Redis client libraries, operating systems, and Redis server software up to date to patch known vulnerabilities. Data encryption at rest. For additional security, consider enabling data encryption at rest. Azure Redis Cache offers this feature for premium tiers. By implementing these security measures and staying vigilant about security best practices, you can greatly enhance the security of your Azure Redis Cache instance, protecting your data and applications from potential threats and unauthorized access. 5. Redis Cache data persistence. Redis Cache data persistence. Data persistence is a crucial aspect of managing data in Redis Cache. While Redis is primarily an in-memory data store known for its speed and low latency, it also provides mechanisms for data persistence to ensure that your data is not lost in case of server crashes or reboots. In Redis, there are two primary methods of data persistence: RDB snapshots and AF logs. 1. RDB snapshots, Redis database snapshots. What is RDB snapshot? RDB snapshots are periodic snapshots of the entire dataset in Redis. These snapshots are stored as binary files on disk and capture the state of the database at a specific point in time. How does it work? Redis creates RDB snapshots at configurable intervals or when explicitly triggered by the user. When Redis needs to create an RDB snapshot, it forks a child process to perform the operation. This child process reads the data from memory and writes it to a binary file on disk. Once the snapshot is complete, the new RDB file replaces the old one. Pros: efficient for backups and disaster recovery. Compact binary format that is storage efficient. Quick to restore data from RDB snapshots. Cons: there might be data loss since snapshots are taken periodically. Forking a child process can briefly impact Redis performance. 2. AF logs, append-only file logs. What are AF logs? AF logs are a detailed, append-only log of all write operations that occur in Redis. Each write operation is logged as a command in a text-based format. AF logs can be used to reconstruct the dataset in Redis. How does it work? Redis continuously appends write commands to the AF file as they happen. This log can grow over time. To recover data, Redis reads and replays the commands from the AF log sequentially when the server starts. This process brings the database back to its last known state. Pros: provides granular and continuous data recovery. Less risk of data loss compared to RDB snapshots. Suitable for durability-focused scenarios. Cons: AF logs can become large and consume disk space. The process of reading and replaying AF logs during Redis startup can be slower than loading an RDB snapshot. Choosing between RDB and AF. The choice between RDB snapshots and AF logs depends on your specific use case and requirements. Use RDB snapshots when you can tolerate some data loss between snapshot intervals and need efficient backups or quicker data restoration. Use AF logs when data loss is unacceptable and you want fine-grained control over durability. However, be aware that AF logs can consume more disk space. Many Redis deployments use a combination of RDB and AF persistence to balance data recovery speed and data loss tolerance. It's important to configure and monitor data persistence settings in Redis Cache to align with your application's needs, recovery time objectives, and data retention policies. Additionally, consider the trade-offs between performance, disk space, and data durability when deciding between RDB and AF persistence. 6. Using Azure Redis Cache with .NET. Azure Redis Cache is a popular choice for caching and storing frequently accessed data in .NET applications. It can significantly improve application performance by reducing database load and latency. Here's a step-by-step guide on how to integrate Azure Redis Cache with .NET. Step 1. Create an Azure Redis Cache. Before you can use Azure Redis Cache in your .NET application, you need to create an Azure Redis Cache instance. Follow the steps in the Getting Started with Azure Redis Cache guide to set up your cache. Step 2. Install the Redis client library. In your .NET project, you'll need to install a Redis client library. One of the most commonly used libraries is Stack Exchange, Redis. You can install it using NuGet Package Manager. Step 3. Configure connection to Azure Redis Cache. You'll need to configure your .NET application to connect to your Azure Redis Cache instance. This typically involves specifying the connection string, which includes the host name, port, and access key. You can retrieve this connection string from the Azure portal as mentioned in the Getting Started guide. Step 4. Store and retrieve data. With the Redis Cache connection established, you can now use it to store and retrieve data. Redis operates with key-value pairs, so you'll need to define a unique key for each piece of data you want to cache. Step 5. Implement caching strategies. To make the most of Azure Redis Cache, consider implementing caching strategies in your .NET application. Here are a few common strategies. Lazy loading. Load data from the cache only when needed and refresh it as necessary. Cache aside, your application code is responsible for managing the cache. When data is requested, check the cache first, and if it's not found, retrieve it from the data source, cache it, and return it to the user. Cache expiry. Set expiration times for cached items to ensure that stale data is periodically refreshed from the source. Step 6. Error handling and cleanup. Make sure to handle exceptions that may occur during cache operations, such as network issues or cache eviction. Additionally, consider implementing cleanup routines to remove expired or unneeded cache items to free up memory. 7. Scaling Azure Redis Cache. Scaling Azure Redis Cache. Scaling your Azure Redis Cache is essential to handle increased workloads, improve performance, and ensure high availability. Azure provides both vertical and horizontal scaling options to accommodate your application's requirements. Here's a step-by-step guide on how to scale Azure Redis Cache. Vertical scaling, scaling up/down. Vertical scaling involves changing the size or performance tier of your existing Azure Redis Cache instance. This can be done without migrating your data to a new cache instance. Step 1. Access the Azure portal. Log into the Azure portal, https://portal.azure.com, using your Azure account credentials. Step 2. Locate your Redis Cache instance. Navigate to the Azure Redis Cache instance you want to scale within your resource group. Step 3. Scale settings. Under the Settings section of your Redis Cache instance, click on Scale. Step 4. Choose a new pricing tier. You'll see a list of available pricing tiers, each with different memory and performance specifications. Choose a new tier that meets your requirements. You can also change the number of shards if you're using clustering. Step 5. Confirm and apply. Review the changes, including the cost implications, and click Apply to initiate the scaling operation. This process may take a few minutes. Horizontal scaling, scaling out. Horizontal scaling involves distributing your workload across multiple Redis cache instances. This is typically done using Redis clustering. Step 1. Plan for Redis clustering. Redis clustering allows you to horizontally scale your Redis cache by partitioning your data across multiple shards nodes. Plan your clustering strategy, including the number of shards and the data distribution. Step 2. Create a new Redis cache cluster. To create a Redis cache cluster, you'll need to provision multiple cache instances and configure them to work together as a cluster. Follow these steps for each cache instance. Create a new Azure Redis Cache instance using the Azure portal, specifying the same resource group and region. Configure each cache instance with a unique port number and specific shard assignment. Ensure that you use a Redis client library that supports clustering, such as Stack Exchange, Redis for .NET. Step 3. Update your application. Modify your application code to be aware of the Redis cache cluster. Redis client supporting clustering will automatically distribute data and requests across the shard instances. Step 4. Monitoring and optimization. After scaling horizontally, closely monitor the performance and health of your Redis cache cluster. Pay attention to metrics like cache hits, cache misses, and latency. Optimize your data distribution and clustering strategy as needed. Considerations. Scaling Redis cache may result in additional costs, so regularly review your cache usage and adjust the scaling options accordingly. Implement load balancing in your application to evenly distribute requests across the Redis cache shards. Maintain a backup and recovery strategy, as Redis clustering can introduce complexity in managing data distribution. By effectively scaling your Azure Redis Cache, you can ensure that your application can handle increased workloads, maintain high performance, and provide a responsive user experience. Remember to continuously monitor and optimize your cache to align with changing requirements. 8. Monitoring and diagnostics in Redis. Monitoring and diagnostics are crucial for ensuring the health, performance, and reliability of your Azure Redis Cache instance. Azure provides several tools and techniques to help you monitor and diagnose your cache effectively. Here's a guide on how to set up monitoring and diagnostics for Azure Redis Cache. Azure Monitor. Azure Monitor is a comprehensive monitoring and alerting service that provides insights into the performance and health of your Azure resources, including Redis Cache. Here's how to set it up. Step 1. Access Azure Monitor. In the Azure portal, go to your Redis Cache instance. Under the Settings section, click on Monitoring. Step 2. Configure metrics and logs. Enable the collection of cache-related metrics and diagnostic logs. You can specify which metrics and log categories to collect based on your monitoring requirements. Step 3. Create alerts. Set up alerts based on specific metric thresholds or conditions. For example, you can create alerts for cache latency, CPU usage, or memory utilization. Redis Cache Metrics. Azure Redis Cache provides built-in metrics that you can access and analyze to gain insights into cache performance. Metrics are available through Azure Monitor, and you can set up custom charts and dashboards to visualize these metrics. Diagnostic logs. Redis Cache also generates diagnostic logs that can help you troubleshoot issues and monitor cache activities. You can configure log retention, and these logs can be sent to various Azure services for further analysis. Third-party monitoring solutions. Consider using third-party monitoring solutions and integrations that are compatible with Azure Redis Cache. Many popular monitoring tools offer Redis Cache integration, making it easier to visualize and analyze cache performance data. Redis CLI. Redis Cache instances support the use of the Redis CLI command line interface for real-time monitoring and diagnostics. You can connect to your cache using the Redis CLI to run commands and retrieve diagnostic information. Redis Slow Log. Redis provides a slow log feature that records commands that exceed a specified execution time. Monitoring the slow log can help you identify performance bottlenecks and optimize cache usage. Azure Application Insights. If your application uses Azure Application Insights, consider integrating it with your Redis cache for more comprehensive application monitoring. Application Insights can capture telemetry data related to cache usage. Regularly review and analyze data. Establish a routine for regularly reviewing and analyzing monitoring data. Look for trends, anomalies, and performance bottlenecks that may require optimization. Proactive alerting. Set up proactive alerting based on predefined thresholds or conditions. Azure Monitor can notify you when metrics exceed specified limits, ensuring that you can take action before performance issues become critical. Optimization and scaling. Use monitoring data to guide optimization efforts, such as scaling your cache or implementing caching strategies more effectively. Security monitoring. Include security monitoring as part of your diagnostics. Monitor access to your cache and configure alerts for suspicious activity. Effective monitoring and diagnostics in Azure Redis Cache help you identify and address performance issues, ensure high availability, and provide a reliable caching service for your applications. Regularly reviewing and analyzing monitoring data is essential for optimizing cache performance and user experience. 9. Azure Redis Session State Management. Azure Redis Cache is a powerful solution for managing session state in web applications. It offers fast and efficient storage for session data, ensuring that user sessions remain responsive and stateful. Here's how to use Azure Redis Cache for session state management in your web application. Step 1. Create an Azure Redis Cache instance. If you haven't already, create an Azure Redis Cache instance by following the steps outlined in the Getting Started with Azure Redis Cache guide. Ensure that the cache instance is in the same region as your web application for optimal performance. Step 2. Install the required NuGet package. In your ASP.NET application, you'll need to install the Microsoft Web.Redis Session State Provider NuGet package. This package provides a session state provider that allows you to store session data in Azure Redis Cache. You can install it using the Package Manager console. Step 3. Configure session state in web.config. In your web application's web.config file, add or modify the session state section to specify the Redis cache as the session state provider. You'll need to provide the connection string to your Azure Redis Cache instance. Replace your _Redis _cache connection string here with the actual connection string for your Azure Redis Cache instance. Step 4. Configure timeout and session settings. You can configure session timeout and other session-related settings in the session state section of your web.config. For example, session state mode equals custom provider equals Redis session state store, timeout equals 20, other session-related settings, /session state. This example sets the session timeout to 20 minutes. Adjust this value based on your application's requirements. Step 5. Use session state in your application. With Azure Redis Cache configured as the session state provider, you can now use session state in your application just like you would with in-process session state. Azure Redis Cache automatically handles the storage and retrieval of session data, ensuring that user sessions are maintained across requests. 10. Redis Cache Geo-Replication. Redis Cache Geo-Replication is a feature that provides high availability and disaster recovery capabilities for your Azure Redis Cache instance by replicating your cache data to a secondary region. This ensures that even if there's an outage in your primary region, you can fail over to the secondary region to maintain access to your cached data. Here's a guide on how to set up Redis Cache Geo-Replication. Step 1. Create your primary Azure Redis Cache. Start by creating your primary Azure Redis Cache instance. This is the cache that will initially store and serve your data. Follow the steps in the Azure portal to create your Redis cache. Step 2. Configure Geo-Replication. Once your primary cache is created, you can configure Geo-Replication by following these steps. In the Azure portal, navigate to your primary Redis cache instance. Under the Settings section, click on Geo-Replication. Click on Create to set up Geo-Replication. Choose the secondary region where you want to replicate your data. This region should be geographically distant from the primary region to ensure redundancy. Click Create to establish the Geo-Replication relationship between your primary and secondary Redis cache instances. Step 3. Monitor and manage Geo-Replication. Once your Geo-Replication is set up, you can monitor and manage it as follows. Monitoring. You can monitor the health and synchronization status of your Geo-Replication pairing in the Azure portal. This allows you to ensure that data is being replicated successfully. Failover. In the event of an outage or planned maintenance in the primary region, you can initiate a failover to promote the secondary Redis cache to become the primary cache. This ensures that your application can continue to operate with minimal downtime. Read-only access. The secondary cache in the Geo-Replication pairing can be used for read-only operations. This can help offload read traffic from the primary cache and improve performance. Failback. After a failover, you can initiate a failback to restore the original primary cache once it's available again. Step 4. Update your application. In your application code, you need to be aware of the Geo-Replication setup. Typically, you connect to the primary Redis cache for both read and write operations. In the event of a failover, you would need to update your application to connect to the new primary, formerly secondary, cache. 11. Using Redis Cache with Azure Functions. Azure Functions is a serverless compute service that allows you to run event-driven code without managing infrastructure. Redis Cache can be seamlessly integrated with Azure Functions to provide caching capabilities, enhance performance, and reduce data retrieval latency. Here's a guide on how to use Redis Cache with Azure Functions. Step 1. Create an Azure Redis Cache. If you don't already have an Azure Redis Cache instance, you'll need to create one. Follow the steps in the Azure portal to create a Redis Cache instance. Make a note of the connection string for later use. Step 2. Create an Azure function. Create a new Azure function or use an existing one. Azure functions can be created through the Azure portal or using tools like Azure Functions CLI or Visual Studio. Step 3. Install the Redis client library. In your Azure Function project, you'll need to install a Redis client library to interact with your Redis cache. One commonly used library is Stack Exchange, Redis. You can install it using NuGet Package Manager. Step 4. Configure connection to Redis cache. In your Azure function code, configure a connection to your Redis cache using the connection string you obtained in Step 1. Here's an example in C#. Step 5. Use Redis Cache in your Azure function. You can now use Redis Cache to store and retrieve data in your Azure function. Redis operates with key-value pairs, so you'll need to define unique keys for your cached data. Here's an example of storing and retrieving data in a C# Azure function. Step 6. Monitor and optimize. Regularly monitor your Azure functions to ensure that Redis Cache is providing the expected performance benefits. Azure Application Insights and Azure Monitor can help you track performance and diagnose any issues. Step 7. Consideration for Azure Functions Consumption Plan. If you're using Azure Functions in a consumption plan, serverless, be mindful of the execution duration and resource constraints. Cache data judiciously and be aware of potential cold start times when accessing Redis Cache for the first time. By integrating Redis Cache with Azure Functions, you can improve the speed and efficiency of data retrieval operations in your serverless applications. This is especially valuable for scenarios where low latency access to frequently used data is essential. 12. Redis Cache Best Practices. Azure Redis Cache is a powerful in-memory data store that can significantly enhance the performance and scalability of your applications. To make the most of Redis Cache and ensure optimal operation, consider these best practices. 1. Choose the right cache size. Select an appropriate cache size based on your data volume and access patterns. Be aware of your application's memory requirements and adjust the cache size as needed. 2. Data modeling. Design your data structures and keys thoughtfully. Redis supports various data types, strings, lists, sets, hashes, etc. Choose the right data structure for your use case to optimize data access. 3. Efficient data storage. Use Redis hashes for storing objects with multiple fields, as this can reduce memory overhead compared to individual keys for each field. 4. Pipelining commands. Redis allows you to pipeline commands, which means sending multiple commands to the server in one go. This reduces the number of round trips between your application and the Redis server, improving performance. 5. Use connection pooling. Implement connection pooling in your application to reduce the overhead of opening and closing connections to Redis. Many Redis client libraries support connection pooling. 6. Proper cache expiry. Set appropriate expiration times for cache keys. Data that is no longer needed should be automatically removed from the cache to free up memory. 7. Redis clustering. For high-throughput scenarios, consider using Redis clustering to horizontally scale your cache. This distributes data across multiple shards, allowing you to handle larger workloads. 8. Monitoring and optimization. Regularly monitor your cache's performance using Azure Monitor and other tools. Analyze cache misses, memory usage, and latency to identify bottlenecks and optimize your usage. 9. Implement caching strategies. Utilize caching strategies such as lazy loading and cache aside to load data into the cache only when needed. This reduces the initial cache fill load and optimizes cache utilization. 10. Avoid hotkeys. Be cautious of hotkeys, keys that are accessed frequently by many clients simultaneously. They can cause contention and slow down your cache. Consider sharding data or using Redis cluster to distribute the load. 11. Enable Redis persistence. If data durability is crucial, consider enabling Redis persistence options like RDB snapshots and AF logs. However, be aware that these options may have a slight impact on write performance. 12. Redis Streams. Redis Streams is a powerful feature for building real-time applications. Utilize it for event-driven architectures or message processing to enhance performance and scalability. 13. Use read replicas. Azure Redis Cache Premium offers read replica support. Utilize read replicas for read-heavy workloads to offload the primary cache and improve read performance. 14. Security and access control. Implement proper security measures, including firewalls, access control lists, ACLs, and encryption to protect your cache and ensure only authorized users can access it. 15. Regularly update client libraries. Keep your Redis client libraries up to date. New versions often come with performance improvements and bug fixes. By following these best practices, you can optimize the performance, scalability, and security of your Redis cache deployment and ensure it meets the specific needs of your application. Redis is a versatile tool, and understanding these best practices will help you harness its full potential. 13. Real-world use cases. Here are some common real-world use cases for Redis Cache. 1. Session state management. Storing user session data in Redis Cache improves the performance and scalability of web applications by reducing the need to query the database for session information. This is particularly useful for maintaining user sessions in e-commerce platforms, social networks, and online banking. 2. Caching API responses. Redis Cache can be used to cache API responses, reducing the load on backend servers and improving response times for users. This is vital for applications that serve large amounts of dynamic content, such as news websites and e-commerce platforms. 3. Real-time analytics. Redis' fast read and write capabilities make it suitable for real-time analytics and data dashboards. It can store and aggregate data from various sources, allowing businesses to make data-driven decisions quickly. Examples include monitoring website traffic, tracking user behavior, and analyzing IoT device data. 4. Pub/sub messaging. Redis publish/subscribe, pub/sub, enables real-time communication between components of an application. It's used in chat applications, notification systems, and live streaming platforms to deliver messages and updates to subscribers as soon as they are published. 10. Inventory management. E-commerce platforms use Redis to manage inventory in real time, ensuring product availability and preventing overselling. This is critical for online retailers and marketplaces. 11. Session Token Storage, JWTs. Redis can securely store and manage JSON Web Tokens, JWTs, used for authentication and authorization in microservices architectures. 12. Caching database queries. By caching frequently used database query results, Redis can alleviate the load on the database and significantly improve application performance. 13. Distributed locks. Redis can be used to implement distributed locks, ensuring mutual exclusion and coordination across multiple application instances or microservices. 14. Content delivery. Redis can cache HTML fragments, images, and other static content for content delivery networks (CDNs) to reduce load times for websites and applications. 15. Fraud detection. Redis real-time capabilities are valuable for fraud detection systems that analyze transactions, user behavior, and payment data to identify and prevent fraudulent activities. 14. Comparing Azure Redis Cache to other Azure caching solutions. Here's a comparison of Azure Redis Cache with Azure Managed Cache and Azure App Service Cache. 1. Azure Redis Cache. In-memory data store. Azure Redis Cache is an in-memory data store that offers extremely fast read and write access. It's suitable for scenarios where low-latency access to frequently used data is essential. Highly configurable, Redis Cache provides fine-grained control over caching settings, allowing you to set cache expiration, eviction policies, and data persistence options, RDB snapshots, AF logs. Supports advanced data structures. Redis supports a wide range of data types and data structures, making it versatile for various use cases including caching, real-time analytics, and more. Geo-Replication. Azure Redis Cache offers geo-replication for high availability and disaster recovery. Pub/sub messaging. Redis supports publish/subscribe, pub/sub messaging, making it suitable for building real-time applications. Pricing. Pricing is based on cache size and tier, with different pricing options available to fit your performance and cost requirements. 2. Azure Managed Cache. Deprecated service. Azure Managed Cache was a service offered by Azure but is now deprecated. Microsoft recommends migrating to Azure Redis Cache for new projects. 3. Azure App Service Cache, formerly Redis Cache. Built on Redis, Azure App Service Cache, formerly known as Redis Cache, is built on top of Redis Cache technology. It's essentially a managed Redis Cache service with simplified management and scaling. Easy integration, it's seamlessly integrated with Azure App Service, making it an excellent choice for web applications hosted on Azure App Service. Managed service. Azure App Service Cache is fully managed, which means Microsoft takes care of maintenance tasks like patching and updates. Scale is needed. You can easily scale Azure App Service Cache as your application's demand grows. Pricing. Pricing is based on the cache size and the number of cache units, allowing you to choose the appropriate level of performance and cost for your application. Choosing between them. Azure Redis Cache is the most versatile and feature-rich caching solution. Choose it when you need fine-grained control, advanced data structures, or specific Redis capabilities like pub/sub messaging or geospatial data. Azure App Service Cache, formerly Redis Cache, is an excellent choice if you're using Azure App Service for your web applications and want to manage Redis Cache with simplified scaling and integration. Azure Managed Cache is deprecated and new projects should avoid using it. Existing users should migrate to Azure Redis Cache or Azure App Service Cache. When deciding between these options, consider your application's requirements, including performance, scalability, and integration with other Azure services. Azure Redis Cache tends to be the preferred choice for many scenarios due to its flexibility and robust feature set. 15. Troubleshooting common Redis cache issues. Troubleshooting common Redis cache issues is essential for maintaining the reliability and performance of your caching solution. Here are some common Redis cache issues and their troubleshooting steps. 1. High cache miss rates. Issue: your Redis cache is experiencing a high cache miss rate, which means that most of the requested data is not found in the cache. Troubleshooting steps. Check if you're caching the right data. Ensure that frequently accessed or expensive to compute data is being cached. Analyze your cache eviction policies. If data is being evicted too quickly, it can lead to high cache miss rates. Monitor your cache usage and adjust the cache size if necessary to accommodate more data. Slow cache response times. Issue: Redis cache response times are slower than expected. Troubleshooting steps. Review your Redis cache configuration. Ensure that you're using an appropriate cache size in performance tier. Check the network latency between your application and Redis cache. High network latency can lead to slower response times. Monitor Redis cache performance metrics using Azure Monitor and identify any bottlenecks. Memory usage concerns. Issue: your Redis cache is running out of memory or using more memory than anticipated. Troubleshooting steps. Analyze the memory usage pattern. Check if your cache is holding more data than expected or if there are memory leaks in your application. Adjust cache eviction policies to free up memory by expiring or evicting less important data. Consider scaling your Redis cache to a larger size or using Redis clustering if memory constraints persist. Connection issues. Issue: your application is experiencing intermittent or frequent connection issues with Redis cache. Troubleshooting steps. Ensure that your Redis client library is up to date. Older versions may have connection-related bugs that are fixed in newer releases. Check for network issues or firewalls that might be blocking Redis cache connections. Implement connection retry logic in your application to handle transient connection failures gracefully. Data inconsistencies. Issue: data stored in Redis cache is inconsistent with data in the source database. Troubleshooting steps. Review your caching strategy. Ensure that you're using the correct caching patterns, example, cache aside or write-through, to maintain data consistency. Implement cache validation mechanisms to refresh or invalidate cache data when the source data changes. Monitor cache expiration settings to ensure that data is not kept in the cache longer than necessary. Authentication and security issues. Issue: problems related to authentication, access control, or data security. Troubleshooting steps. Verify that you're using the correct access keys or connection strings to authenticate with Redis cache. Review and update access control lists, ACLs, and firewall rules as needed. Ensure that sensitive data stored in Redis cache is appropriately encrypted. Geo-replication failures. Issue: Geo-replication between primary and secondary Redis cache instances is not working as expected. Troubleshooting steps. Check the status of geo-replication in the Azure portal and ensure that the secondary cache is healthy and synchronized. Review network and firewall settings to ensure that geo-replication traffic is not blocked. High CPU usage. Issue: Redis cache is experiencing high CPU usage. Troubleshooting steps. Analyze the Redis commands being executed. Complex or computationally intensive commands can lead to high CPU usage. Monitor Redis clients and identify any clients that may be causing excessive load on the cache. Consider optimizing your application code to reduce the number of Redis cache calls. Logs and monitoring. Issue: lack of visibility into cache performance and issues. Troubleshooting steps. Enable logging and monitoring for your Redis cache instance. Use Azure Monitor, Diagnostic logs, and performance metrics to gain insights into cache behavior. Implement alerting based on key cache metrics to proactively identify and address issues. When troubleshooting Redis cache issues, it's crucial to combine a proactive approach with monitoring, performance analysis, and a thorough understanding of your application's caching requirements. By addressing issues promptly and implementing best practices, you can maintain a reliable and high-performance caching solution.
Hey, if you like the content, please subscribe to my channel. Don't forget to ring the notification bell so you never miss a bite of Azure brilliance.